So this is about T cell development. T cell, first early T precursor cell are formed in bone marrow, and then it goes to cortex, it goes to thymus, and within the thymus it goes to cortex, and that's when it becomes T cell precursor cells. And after that it goes to medulla. The reason why we go through these both steps is that so at the bone marrow, they go through the selection process to see if it reacts with its own antigen, but not all self antigen is in bone marrow, and so that's why it goes to thymus, and in the cortex it does extra testing to ensure that it's not reacting with oneself. And when it's in bone marrow, it's still stromal cells, and so this could technically it isn't T cells, and it could be like B cells and some other cells as well. So after it goes from bone marrow to the thymus in the cortex, it goes to the Notch receptor get activated, and Notch receptor activate the GATA3 transcript factors and makes it into an actual T lineage cells. And in the process of T cell development, there's a few steps to be aware of, and that is that double negative, which means that the CD4 and CD8 are both not present, and double positive, that means both CD4 and 8 are present, and that means it could be either both CTs, helper cells, or cytotoxic cells. So it's undecided, and it could be either one. And then it becomes single positive, and then it will know whether it wants to be or CD4 or CD8 cells. So to talk more about the double negative, there are 4 steps in the double negative. So once at double negative 1, that's when it goes from bone marrow to thymus, and then other stuff happens within the thymus. So double negative 1 has CD44, and CD2, but does not have CD25. And once it goes to the next step of double negative 2, it has CD44 and has CD25. If you go to double negative 3, it does not have CD44 and it still has CD25, and at the end, double negative 4, neither these 44 or 25 are present. So on the double negative 1 and double negative 2, that's when the recombination of DJ and VDJ recombination happens and form the beta heavy chain. And once it has the beta heavy chain, similar to the B cell development, it tests whether the beta heavy chain works with the surrogate light chain. And that is not real light chain, but it's just for the test purposes of whether the beta heavy chain they made works. And if it binds well with the surrogate light chains, then we know it's good, and it will proliferate and make more copies of it, of the beta heavy chain that they made. And if it's not good, then they'll try a different heavy chain, so as earlier here, they can try their mom and dad, so paternal and maternal, and they could, paternal and maternal, they check. And once it's after that step, so that was the double negative 2, and we move on to double negative 3, and they will do VJ recombination of the light chain as well, and so that we can attach the real light chain instead of the surrogate light chain. And after that step is done, we move on to double positive, and then we move on to single positive. And the reason why the light chain looks like this is what the end product will look like, and this thing is light chain, and this is heavy chain.